Hi everyone, in today's segment we'll talk about the infrared spectroscopy. Infrared spectroscopy or IR spectroscopy are used to detect or to determine the functional group of a compound. This type of spectroscopy are used to detect the functional group of a compound Here in IR spectroscopy, in place of electromagnetic radiation, IR radiation are used. Infrared radiations are used. Infrared radiation are used for a sample in order to detect the functional group of a sample or of a compound. For example, formaldehyde. This is the formula of formaldehyde. In this formaldehyde, some interatomic bonds are present which play the most important role in the detection of the functional group of this formaldehyde. This is the interatomic bond which is present, the carbon and hydrogen. Interatomic bond. This is the interatomic bond which is present between the carbon and hydrogen. First of all, we will provide the infrared radiation toward this sample, toward this formaldehyde. For example, this is the infrared radiation. This is the infrared radiation, which consists of different wavelengths. Here the wavelengths are different. The wavelength of this IR radiation are different from one another. Here the sample are placed in front of this radiation. This is the sample. For example, formaldehyde. This formaldehyde are placed in front of the infrared radiation. So if we bombarded the infrared radiation toward this sample, this formaldehyde will absorb a specific type of specific wavelength of radiation. They will not absorb all the radiation, all the infrared radiation. They will absorb some radiation. They will absorb the radiation. When they absorb the radiation, the interatomic bond which is present, the carbon and hydrogen, behave like a spring. This interatomic bond will behave like a spring and they will cause the vibrational rotational spectra. This interatomic bond behave like a spring, and they will cause different types of vibration. Two types of vibration are possible here between this interatomic bond. One is stretching and the other is bending. They will cause the stretching or bending vibration. When they cause the vibration, when they behave like a spring, so from this vibration we can easily determine the functional group of this formaldehyde. Here in front of this sample, detector are present. This is detector. In front of detector, some spectral line are produced due to the absorption of this, due to the absorption and transmission of this formaldehyde. Some wavelength which is not specific for this formaldehyde, they will transmit it from this formaldehyde and move toward the detector. From detector, they will also pass. So here they will produce some spectral lines. Here this spectral line, the y-axis will represent the transmittance. They will represent the transmittance, and the x-axis line will represent the wave number. Here a straight line will show the transmittance of formaldehyde or sample. This type of peak will produce. This peak will represent the absorbance. From this peak, from this absorbance, we can easily determine the functional group of a compound, and we can match this absorbance peak with the reference list. And this straight line will represent the transmittance, and this will represent the fingerprinting. This will represent three types of peak will be produced. A straight line peak will represent the transmittance of a sample. This peak will represent the absorbance of a sample. So the main here in infrared spectroscopy, this is the main peak. This is the main spectra. From this spectra, we will easily detect the functional group of this sample, such as the formaldehyde. And we can match this absorbance peak with the reference list of this compound. And this different fingerprinting, this will show the fingerprinting of a sample. Now we will talk about that which type of vibration and bending are produced by a sample. There are two types of vibration which is possible here, stretching and bending. So what is stretching and bending types of vibration? Now here two types of vibration are possible here in infrared spectroscopy. One is stretching and the other is bending. First is stretching. Stretching are further divided into symmetrical and asymmetrical stretching. In symmetrical stretching, in symmetrical stretching, the interatomic bond between two atoms will be increased or decreased at the same time. Both of the symmetrical stretching. For example, this is the hydrogen. Now symmetrical. For example, this is one atom. This is one atom, and this types of vibration are produced between these atoms. This is the interatomic bond. In symmetrical stretching, both of the interatomic bond spring will be increases or decreases at the same time. This both will be increases or decreases at the same time. This is the symmetrical stretching. Now the asymmetrical stretching, second is asymmetrical stretching. In asymmetrical stretching, one of the interatomic bond, one of the spring will be increases and the other will be decreases. They will not be same. For example, this is one atom, this is another. The distance of this spring, the distance, this interatomic bond will be decreases and this will be increases. They will not the same. This is the asymmetrical stretching. Now second types of vibration is bending. Bending is the simple phenomena. For example, this is the one atom, this will and this is the another atom, they will bend toward this. This is bending. This type of vibration are called bending. So here they will further divided into scissoring. And scissoring, for example, this is one atom, this is the interatomic bond present between these two atoms. Scissoring moment will be occur here. Scissoring moment will be occur. They will move toward upside and they will move toward lower side. Like a scissor, they will move like this. So they will move toward upside, they will move toward lower side, and this will be like a spring. This interatomic bond will behave like a spring. So scissoring movement will be occur in scissoring types of bending. Second is rocking. In rocking, both of the atoms will move toward upside or toward lower side. This both atom will move toward this or move toward this. At the same time, both of the interatomic bond will move toward upside or right side, and they will behave like a spring. This is rocking. Third one is wagging. In wagging, for example, this is the flame. In wagging, this atom will move above the plane or below the plane. For example, this is the plane. For example, this is the plane. So this this atom will be moved like this or this. They will move like this. They will above the plane or below the plane. Both of the atoms, they will move like this, above the plane or below the plane. Third one is twisting. In twisting, one of the atoms move above the plane and the other will move toward below the plane. Here in wagging, both of the atoms are move above the plane or below the plane, but here in twisting, one of the atoms are above the plane and the other is below the plane. For example, this is the plane. So this will move above the plane and the other will be below the plane. So two types here, some difficulty are present here. In wagging, both of the atoms are moved below the plane or above the plane, but in twisting, one of the atom above the plane and the other atomic bond which is present between two atoms are below the plane. So that's all about the different types of vibration which is present in infrared spectroscopy. Now we will discuss about the main principle of the IR spectroscopy. What is the main principle of the IR spectroscopy? Principle. The main principle of the IR spectroscopy is absorbance and transmittance. Absorption and transmittance. Mainly from the absorbance of IR spectroscopy, we can easily detect the functional group of a compound. This absorption are very damn helpful here in the IR spectroscopy. So this is the main principle of the IR spectroscopy, absorption and transmission. First of all, if we bombarded the infrared radiation, from a sample, so the sample will be absorb some wavelength of radiation and some will be transmitted from this sample. If they absorb some radiation, this will be the main characteristic of a functional group of a compound. This absorption will be the main characteristic of functional group of a compound, and some are transmitted from this sample. From this absorption, we will easily determine the functional group of a compound. This is the main principle of a infrared spectroscopy: absorption and transmission. From absorption, if a sample absorb some radiation, some infrared radiation, they will behave like a spring. If they behave like a spring, they will cause some vibrational rotational spectra. From this vibrational rotational spectra, such as stretching or bending, from this we will easily detect the functional group of a compound. So this is the main principle of IR spectroscopy. In the next section, we will talk about the instrumentation of IR spectroscopy and some other important point of IR spectroscopy.